Energy is the capacity to do the work. This is what is energy. So what and energy are very related. What is the work done? When the four is a four only that one starts there and starts there and move, so that it can be the work done happen. So energy means the ability to do the work. So this is the energy. So energy can be the two energy, potential energy and kinetic energy. So potential energy means when the subject is above the ground level, so it can be the potential energy. When the subject is moving at the constant speed, and that will also be the kinetic energy. So potential energy and kinetic energies are utilized in describing the energy. If the locomotive is moving at the top, 2 meter per second square, acceleration and it's a weight at the 1/2 in the tempo of 6 Newton. So this is the way to find the kinetic energy. So the locomotive moves for the 3/2 in the tempo of 3 meter. Calculate the velocity. So v square is equal to the u square plus 2af. So in this case, our final velocity will be we have to calculate velocity because of the when we want to calculate the ke, the half mv square. So firstly you need to calculate the velocity v square. So v square is u square is 0 square. So the acceleration is 0.26 meter per second, and the distance is 3.2 into 10 power 3 meter. So therefore you can get a v square. So v square is 0.40. So this is a v square is 2 into 0.26 multiply 3.2 into 10 power 3. So v is you can calculate square root of 2 into 0.26 multiply 3.2 into 10 power 3. So the velocity will be 40.8 meter per second. Okay, in the meantime, you also need to calculate this mass. Mass is for example, this is for the force. Force the weight is 1/2 10 power 6 Newton. So force is equal to you can calculate m into g. So in this case, force is 1.2 into 10 power 6 Newton. So we don't know the mass. Gravitation is 9.81, so that you can calculate the mass. 1/2 into 10 power 6 divided by 9.81. So the mass we can calculate, that will be 1.22 into 10 power 5 kilogram. And after that, you can calculate the ke, kinetic energy. So half into mv square. Half into mass is 1.22 into 10 power 5. Velocity square is 40.8 square. So by solving this kinetic energy will be 2 into 10 power 8 joules. So this is the way we can calculate the kinetic energy. So what is the energy transfer from object by means of the force? When the force is acting on the object will be moving. So once the object moves, the work will become. So this is what is the energy transfer to or from an object by means of the force acting on the object. So energy transfer to the object is a positive work, and energy transfer from the object is a negative work. Calculate the work here. This is the surface is. So this is for the force. So this is the angle theta. So this is our distance. So this F is that you can divide the two components. This is the F cos theta. So the work is equal to F cos theta into D. So this is you know with the joules. So by this is that we can calculate the work. Work is equal to this is for the parallel force. There are two forces. That component is a partial component. It's not applicable. Only the horizontal component. So this F can be divided into two components. We calculate the horizontal component and then multiply with distance so that we can calculate the force. Well, so F cos theta is a horizontal component, multiply with D so you can calculate the work. The work will be the joule. For the two force, the first one is a 30 degrees. It's a different, and force is a 40 degrees. So force one is a 12 Newton at the 30 degree, force two is a 10 Newton at the 40 degree. So the object is moved, the 8.5 meter. So we have to calculate the total work. So the W1 is a cos by the force 1, and W2 is cos by the force 2. So W1 you will calculate it, F1 cos theta 1 into d. So therefore the force y is a 12 Newton, cos theta y is cos 30 into this is 8.5. So by this way you can calculate the W1. So the W1 will be 8.33 joule. And also the W2. So F2 cos theta 2 into d. So the F2 is 10 Newton, cos 40 into 8.5. So by solving this one, W2 will be calculated. There will be 65.11 joule. So the W2 is equal to W1 plus W2. So there will be 88.33 plus 65.11. So there will be 153 joules. By this way, we can calculate that total work. The next one will be we have to calculate the velocity. What time is 153.4 joules and mass is 225 kilogram. We have to calculate velocity. So the kinetic velocity half into mv square is the 1 watt time. So the half into mass is 225 and velocity square is total. But the watt is 153.4. So the v square is equal to the 2 into 153.4 divided by 225. So v is equal to square root of 2 into 153.4 and 225. And then we can calculate the velocity. So this velocity will be 1.17 meter per second. Spring. So this is for the spring here. Spring constant K, and this one is a frictionless. Frictionless surface, and this is a mass M. Mass M was a velocity V. They sit as a spring. So spring will be a compressing to the distance D. So we have to calculate the distance. So the equation to calculate the distance is this we can as Kf minus Ki is equal to minus half into K into D square. Kf means this is space constant. Kf is friction constant. Ki is the initial kinetic energy. So this is Kf is the final kinetic energy. Final kinetic energy. And Ki means the initial kinetic energy. So kinetic energy we can calculate. The formula is that Ke is equal to half into m into v square. So this is the kinetic energy equation. So final velocity is a Vs. It's 0. Initial velocity Vi. We have to calculate. So initial velocity is 0.5 meter per second. 0.5 meter per second. So in this case we substitute half into m into Vs square minus half into m into Vi square is equal to minus 1/2, and the spring constant is 750 Newton per meter, and d is we don't know the d, so that we have to calculate. So in this case final velocity is 0, so half into minus m here, final velocity 0 square minus half into m, initial velocity is 0.5 square minus half into 750 into d square. So then you can calculate. So in this case, the mass is 0.4. So this is minus half. So this one is 0. So mass is 0.4 kilogram into 0.5 square. So minus half into 750 into d square. So then by solving this one, 0.4 into 0.5 square is 750 into d square. So we can calculate the d. This is d. So d can be calculated. So square root of 0.4 into 0.5 square divided by 750. So this can be calculated is 1/2 into 10 power minus 2 meter or 1/2 centimeter. This way we can calculate the system. Object above the ground level, they call the potential energy. So this is the H, so minus the M. So vibration is G. So the potential energy P is the potential energy. Is equal to mg into h. So this is for the h is the height, this is the gravitation, and this is the mass. So we can calculate potential energy. So this is the mgh. In the meantime, conservation of the mechanical energy. Conservation of mechanical energy. So we can write down the equation for the conservation of the mechanical energy. So E is the mechanical energy. E is a mechanical is equal to K plus U. So this is the equation for the mechanical energy. In this case, E mechanical is a mechanical energy. Sound the potential. So this is for the E mechanical. So mechanical energy. E mechanical is a mechanical energy. And K means the kinetic energy, U means the potential energy. So the mechanical energy is equal to the kinetic energy plus the potential energy. So the E is the mechanical energy. K, kinetic energy. Q, potential energy. So we can write down the equation mechanical energy is equal to K plus U. Force can happen when the energy level change from the one level to another level. When the energy is changed, force can also be happen. In this case, this graph, initial energy is 20 and final energy is 7. So 20 to 7 will be changing. So this way also changing. This way is a 1 to 4 will be changing. So that we can calculate the force. The force equation is change of energy divided by change of distance. So in this case, our initial energy is 20 joule. Initial potential energy is 20 joule. Final potential energy go down to 7 joule. And this case, the initial distance is 1 meter. And final area is 4 meter. So that will be the 13 divided by minus 3. So that will be the minus 4 by 3 Newton. So this minus 4 by 3 Newton, the force will be acting on the object, so the energy will be changing. So from this graph up, you can calculate how we can calculate the force of the change of the energy and change of the distance. So that the equation the force is equal to change of the energy divided by change of the distance, then we can calculate the force. Tonight's lesson. So tonight I start the energy. So energy can be the kinetic energy and potential energy. So the kinetic energy is state of the motion of the object. K is a half mv squared. We can calculate. Then the first problem is that we calculate the velocity. Then we calculate the mass and we calculate the KE. Second problem is that we can calculate the equation. So when there's a force engaged at theta, you have to determine the horizontal force. Horizontal force multiplied distance, then we can calculate the work time. So this is for the second problem. And third problem is that we can calculate for the velocity. If you know that work time and the mass, you can calculate the velocity. And fourth problem is the separating problem. For the separating problem, initial final kinetic energy minus initial kinetic energy is a half into K into D squared. So K is a space constant, D is a distance. And then I give you the formula for the potential energy formula and mechanical energy is a formula. Mechanical energy is equal to the kinetic plus the potential energy. So from this graph, we can calculate for the force, so the share of the energy divided by share of the distance, we can calculate the force. Energy is